All right, Gibson here. Today we're going to continue on in our unit on rational functions and look at how do we work with rational expressions. So kind of procedural today, a lot of just kind of basic algebra stuff. So let's take a look at what we're going to be able to do. First is, what does it mean to simplify a rational expression? And then how do we multiply and divide rational expressions? All right, so first off, what does it mean to simplify a rational expression? Well, a rational expression is in its simplest form when its numerator and denominator are polynomials, right? So polynomial, again, is just one or more terms, and that those expressions have no common divisors. In other words, we've divided out or simplified out any common divisors. You guys sometimes use the word cancel. So let's look at an example of some rational expressions and see if they are in their simplest form. So here's the first one, right? X divided by x minus 1. There are no common factors or divisors. You might be tempted to say, well, can we divide out the x? But we can't. The x is a factor in the numerator, but x minus 1, it's an expression, right? A term and an expression. So we can't divide x's out. This would be simplest form. Here's another example, right? 2 over x squared plus 3. Again, clearly nothing common, no common factors or divisors that we could simplify. Now let's look at an example that are not in the simplest form, right? We have x divided by x squared. So here we see we could divide out a x, right, in each one. If we divide an x out of the numerator, we're left with 1. And if we divide x out of the denominator, we're left with 1x, okay? Here's another example with 2 factors, right? 2 times x plus 3 and 3 times x plus 2, rather. So clearly we could divide out the x plus 2's. Those are common factors or common divisors. You could think of it either way. So that's what it means to simplify. So let's look at some examples, right? We'll look at a couple different types of expressions and how we would simplify them. So here's one where we have all factors in both the numerator and the denominator, okay? So let's just begin. We want to divide out those common factors. We also want to state any restrictions on the variable. And a restriction is any value that makes the denominator equal to 0. Gosh, that sounds familiar, right? We've been talking about the zeros of a rational expression. Same thing, the restriction is just what values of x would make it equal to 0. Okay, so that's kind of the last step we do. But let's go ahead and simplify this. So first we see we could divide a y out of each expression, numerator and denominator. We could also divide out an x cubed. That's just going to leave us with an x in the denominator. And 27 and 9, right? We could divide both of those by 9. We would have -3 in the numerator and +1. So what's left here? We have a -3 in the top and a x in the bottom. Okay, so there we have it, our simplified form. Now let's state in restrictions, and we always want to go back to the original expression to identify our restrictions, because notice in our final answer we only have x in the denominator, so that would be one restriction, right? X cannot be equal to 0. But in the original problem we also had y in the denominator. So we want to look at the expression before we simplify it. So in this case, neither x or y, right, can be equal to 0. That would make it undefined. So those are our restrictions. All right, let's look at a couple more examples here. 2x plus 1 divided by 6x squared plus 3x. Now, we've got 2 expressions, and we always want to ask ourselves, can we factor either one? That's always a good first step, right? Factor to find any common divisors. So we can't factor anything in the numerator, but we can factor out a 3x in the denominator. So let's do that. If we pull out a 3x, we would then have 2x plus 1 in the denominator. And now notice we have a common divisor, right? We could divide out 2x plus 1 And what do we have left? We have left 1 over 3x. Okay, now restrictions. What are our restrictions? We're going to go back, excuse me, to the original problem, but in its factored form, okay, before we simplify, because in factored form, it's much easier to find our restrictions. So what would those be? Well, the 3x, right, x cannot be equal to 0. The 2x plus 1, let's write a little equation and solve for x. So we would subtract 1 and then divide by 2. So x cannot be equal to 1/2. Let's add that to our restrictions. All right, one more example here, and then we'll get on to multiplying and dividing. Notice we now have a quadratic in the numerator, so we need to factor that, right? You guys know how to factor a quadratic, right? We would factor that into n plus 1 and n plus 5. And now we see that we do have a common divisor that we can divide out. And we're just simply left with n plus 5. Now, final answer, there would be no restrictions, right? But we need to go back to our factored form before we simplified and see if we have restrictions. And notice we have the n plus 1 in the denominator. So that means n could not be equal to a -1. All right. How about if we're multiplying rational expressions? How does that work? Well, it actually works the same thing as simplifying. We just have a few more places to look for common divisors that we can simplify out. So here's an example, right? Let's factor numerators and denominators. Well, they're all pretty much already in factored form, right? So we're good there. The question is, can we divide out some common factors? And you notice we have x's in both the numerator and denominator. We have y's in both the numerator and denominator. We've got some integers that we can simplify. So let's step through that. The first step is 7 and 21. We can divide both of those by 7. 12 and 24, right? We can divide both of those by 12. And then we've got an x to the 4th and a x. We can divide out one of the x's, leaving us with x to the 3rd. And then similar to the y's, right? We can divide out a y to the 4th. That's just going to leave us with y in the denominator. All right, kind of messy here. So let's rewrite it. What do we have left in the numerator? We really just have x cubed. And in the denominator, we have 2 times 3y, or let's go ahead and multiply that together and get 6y. Okay, so there's our simplified form. Restrictions. Let's go back and notice in the original problem, right, we had both x and y in the denominator as a factor. So x would not be equal to 0 and y would not be equal to 0. All right, let's look at another example, multiplying. Here we can do some factoring, right, before we simplify. So let's do that. So the 3x, right, nothing we can factor there. But the 4x minus 4, we can factor out of 4. 2x minus 1, nothing to factor there. 3x plus 6, we can factor out a 3. Okay, we have it factored. Now let's divide out the common factors. So we can divide out a 3. We could divide out the 2x minus 1, and what's left? We have x over 4 times x plus 2. Now, restrictions. So remember, we go back to our factored form before we simplified. So we have a 2x minus 1 and an x plus 2. So -2, right, would be the restriction on x plus 2. And 2x minus 1, let's add 1 and divide by 2, and we would get a positive 1/2. All right, one more example here. See if you can do this one. Pause the video and see if you can work this out. We've got some quadratics that we need to factor here. All right, here we go. So here's how everything's going to factor, right? This top quadratic can be factored to x minus 5 and x plus 5. The numerator, x plus 2 and x plus 4. The numerator here, x minus 4 and x plus 2, and then x minus 5, nothing to factor there. All right, now what can we simplify? Well, let's get rid of the x minus 5s. We've got x minus 2, and that's it. Right? We can't do the x minus 4 and x plus 4. They don't have the same sign. So here's our simplified form. Now restrictions, remember we go back to factor form before we simplified. So let's just walk through this, right? We're going to have a -2 for the first factor, a -4 for the second one, and a +5 for the last one. All right, now last part, dividing rational expressions. How do we divide a fraction? Well, you know this, right? We can multiply by its reciprocal. So let's see what that would look like. Let's just start with very simple rational expressions, just integers here. 5 divided by 16, or 5/16 divided by 15/8. Well, we're going to multiply by the reciprocal. So 15/8 becomes 8/15, and now we can simplify. So we can divide out a 5, we can divide out an 8, and what are we left with? 1/2 times 1/3, or 1/6. No restrictions in this case, right? We don't have any variables in the denominator. All right, let's try one with some variables here. So rewrite as multiplication, right? Divide by the reciprocal. So we're just going to take 9x³ over 16y and flip it. Now we're right back to simplifying. So what can we divide out? We can divide out a 3, actually a 3x, right? And we're just left with 3x². We can divide out a 4y, and we're left with y, right? So I'm dividing both the integers and the variables out here in the same step. So what do we have left? We've got 4 in the top and y times 3x² in the bottom. Let's simplify that. And restrictions, notice we had both x and y in the denominator. So we would have x not equal to 0 and y not equal to 0. All right, let's look at another one. Division, and notice everything's factored for us already here. So all we have to do is rewrite it as multiplication, taking the reciprocal of the second rational expression. So we just flip all that over and now simplify, right? What can we divide out? All right, here's x minus 4 and x minus 2. And that's it, right? So here's our simplified form. Now, when we find restrictions for division problems, we have to go back to the original factored form, and we have to look at also what was originally in the denominator to begin with before we took the reciprocal and turned it into a multiplication problem. So we actually have kind of 3 places to look in this problem, right? So what are the restrictions? 3x plus 2, that would give us a restriction of -2/3, right? X minus 2, we had it twice. We don't have to do it, list it twice. That would give us a restriction of +2. And then 7x minus 5, if we add 5 and divide by 7, right, we get 5/7. And now here, notice the x minus 4, while it started in the numerator, when we rewrote it as multiplication, it wound up in the denominator. So we also need to include that in our restrictions. So that would be a 4. So lots of restrictions on this problem. All right, one more here. See if you can do this one yourself. All right, here we go. Rewrite as multiplication, and let's start simplifying. So we can divide out a 5. We can divide out a 8y squared, and that leaves us with 3 and 1. So let's write it all together. We have 1/1 times 3/4x³, or just simply 3/4x³. Restrictions. Well, we have both x and y in the denominator. So x cannot be equal to 0 and y cannot be equal to 0. All right, one more for you to try. So I'm not going to say anything. I'm just going to step through and let you follow. And there we go. 0 and 5 would be our restrictions. All right, that's it. So we know how to simplify rational expressions and we know how to multiply and divide. And when we're dividing, we have to, actually for any of these, right, we always want to state our restrictions, the values that would make the denominator equal to 0.